In this video, we will demonstrate the wet pluviation of fly ash. We have a 2.8-inch diameter split mold lined with a latex membrane. The membrane is stretched open by a vacuum of 0.7 kilogram per centimeter squared, and we have already placed at the bottom of the split mold a porous stone and filter paper. And at this point, the split mold has been filled with water. Mounted above the split mold, we have a 1-liter flask with its opening at a predetermined height from the bottom stone, and the flask has a pre-measured quantity of fly ash mixed together with water.
Using this method and vibration which we will use, we have achieved relative density between 60 to 62%. Our acceptable range of relative density is between 60 to 65% for this series of tests. Maintaining relative density is important since shear and cyclic strength is dependent on it.
Right now we have a cork holding the mixture in the flask, and when we remove the cork, we will initiate pluviation. Now we have removed the cork from the bottom of the flask, and we can see that fly ash is descending and an equal volume of water is being replaced by the flask. Now we will turn on a vibration source to help expedite the pluviation. Depending on the type of fly ash, pluviation requires between 2 to 4 hours to complete. Additional time may be required to deposit finer particles.
Now pluviation is complete. You may observe that we have no visible fly ash in the flask. We can carefully remove the flask so it does not disturb top of our specimen. Now that the flask is removed, we can place the top filter paper, porous stone and loading cap.
We have already connected both sets of supply lines to the valves on the base of the triaxial cell. One set of lines will be connected to the triaxial panel to supply water pressure during consolidation, and the other set of lines is connected to a regulated vacuum source. When we open the valves on the base of the triaxial cell, a vacuum of 0.2 kilogram per centimeter squared is applied to the sample and will be maintained for 10 minutes. Before vacuum can be applied to the specimen, we need to move the membrane from the top of the split mold to the sample loading cap. We've also rolled up 2 rubber O-rings to help with the seal. Now we will open the valves to apply vacuum to the sample. It has been 10 minutes since we've applied the vacuum, and now we can close the valve to the vacuum supply and monitor the vacuum gauge for about 5 minutes. We will only proceed if we don't have any leaks.
It has been 5 minutes since we have closed vacuum. We are observing that vacuum is holding, so we can now proceed to dismantling the split mold.
We have already removed the split mold and we can observe our sample. The consistency at this point is semi-solid. Before we proceed to mounting in the triaxial chamber, we will take measurements with calipers of the diameter and the height.
At this point, we can observe that vacuum is holding the shape of our sample. Without this vacuum, the sample would have slumped. Now we have assembled the chamber and we have applied 5 psi cell pressure and 2 psi back pressure. We have also purged all lines to remove air. The sample will now saturate until it has reached a minimum 0.95 B value. From experience, we have observed that about 10 psi back pressure is enough for saturation. Once sample is saturated, it shall be consolidated to pre-specified effective stress. Thank you for watching.